Hi viewers, and today we're going to be looking at making graphical user interfaces, also known as GUIs, to actually control a timer based animation. This can be used to control any type of animation actually, as long as we can actually place buttons on screen to actually control angle, positioning, etc. This allows us to actually hook into the timer and allows us to start and stop it without actually pasting code into our Python console. Now there's other things that we can actually use this for. If we're controlling the animation, say of a spinning part, we could actually develop, as I'm demonstrating here, develop the part in real time as it spins. You may want to decrease the animation a bit by decreasing the angle or increasing the timer, because it can get a bit nauseating when it's spinning fast. So decreasing the rotation means that you can actually have your parts rotating as you're adding geometry or doing operations on your part. But the main concept of this is actually creating a GUI to allow you to actually create your animation and control your animation in a more of a controlled way. Okay, so let's have a look at actually doing this. Okay, so we're going to start the macro. So we go to macros, create a new macro, and animation controller, I'm going to call it. So we've got a new macro, and the first thing we need to do is import the actual libraries. So I'm going to be using, from Pi side, I'm going to be using a number of libraries from here and import Qt GUI. So that holds the Qt widget library we need for the actual creating of the window and the actual buttons. And we're going to be extending Qt widget in a moment. So to actually do this, we need to actually use object-oriented Python to actually create a object to hold the window and all our code related to that window. So I've added some few basic lines in here to actually create the GUI. So we've got class, which we use to actually create the object. I've called the class my GUI, so this can be anything you like. Open and close bracket and use the colon on there, so anything tabbed over, so this is a tab here, so anything tabbed over is inside the actual class, and we've got a define here, a def method, and we're using a double underscore init double underscore, and then we're passing a variable called self. Now what we've got here is basically the initialization method for the class, the constructor, and underneath that I've tabbed over once and I've just issued the command print init. So I'll run this won't actually work because we haven't actually created an instance of this. We've just created an object. It's not actually instantiated and it's not actually running. So to do that, we just need to create a variable. I'm going to call it GUI equals my GUI. Open and close brackets. And when I run that now, you can see down here it's come up in my report view, which is available from View, Panels, Report View. It's actually come up in it down here. So that is a basic class utilizing the constructor. We will now need to extend this to actually pull in the Qt widget. So if I'm running this class and in here I put Qt GUI dot QWidget, I'm actually extending QWidget here. So I'm taking on all of the methods, all of the properties of QWidget and extending it in a new object. And that's important because we're going to be using QWidget in our actual class. But to allow us to use QWidget in the class, we need to actually add some more code in here to call the constructor of QWidget. All sounds a bit complex, but you'll understand once we get some code in here. So in my constructor here, the underscore init underscore, we'll jump into here and add the command super bracket my GUI, which is the class, self, which is the variable that is sitting inside the constructor there, and we're calling dot underscore init underscore and open and close. So we're actually calling the construct method of the Q widget there. And the reason why is because super is what's been extended, which is the qtgui.qwidget. So we're actually calling the constructor of the Q widget, and that will run the actual constructor, and means that we now have the methods and properties available what we need to actually create our window. Now I'm going to, in here, actually if we run this, just double check it's still running. Yep. So in here we're going to actually start defining our window. So I'm going to get rid of this print, don't need that anymore, and in here I'm just going to put a remark, which is the hash, and put window. So this won't get run, it's just a comment to show what we're actually doing. So in here I'm going to actually start creating our window. Now one thing that I want the window to be is actually stay on top of all the other windows. So when we actually swap over to, say, a scene, if our scene's open, say this was a scene, it will still be sitting on top of this window. So we don't want it to start the GUI and then when we swap to another scene it disappears below all the windows. So self.set window flags, so we're referencing this class here, so self dot set windows flags. So we're actually telling the window that we need it to actually take notice of the flags that we're passing in, so we're going to give it some properties for the actual window. So qtcore qt dot window stays on top hint. So that makes sure it stays on top of any of the actual windows that we actually got open. So if we run this now, it's saying Qt core not defined. So we need to import the Qt core in here. So we just put comma, Qt core, run that again. Let's clear this. So nothing's happening as of yet, and that's because we haven't actually shown the window. So if we come over and go self.show, this will actually show the window now. So we've actually got a window that's popped up, and that's because that self is this class, but remember we've taken on all the properties and methods of Qt widget. So in Qt widget there is actually a method called show, which will actually show a window on screen, and that's all we're doing there. Because if we did self.show here, if we had a method in this class called, say, show, I'm going to pass in self in here, then if I did something simple as print show in here, what will happen is that this will now actually run this method instead, rather than the method on the Q widget. As you can see down here, it's saying showing show. So if I remove that, because there's no method in the actual class itself, it looks back to its superclass, which is Q widget, and shows a window. Now we've got a window screen, we can set other things like the size and the titling of the window. but I'm just going to give it a title. You can do that by self.setWindowTitle, and I'm going to call it animation GUI. So when I run that, I've got the title there, animation GUI. And now I'm going to define a few buttons for this window. So in here, I'm going to place the buttons. And for the buttons, I'm going to use the self dot, and then I'm going to call it, so this is a variable. So I've assigned a variable to self. So what that's done is put the variable into our object called BT start, and I define it as a Qt GUI dot Q push button. Give it a name as start, and also you have to pass in self, so you pass in the class. We can create another button, self dot BT underscore stop. You can call these what you want as long as you start with self dot, and what you need to do is also give that Qt GUI dot Q push button, and in here give it a title and pass in self. Now if I run this, the buttons won't show, and that's because we haven't actually added them to the screen yet. To add them to the screen, you need to define them in a layout. So in here, I'm just going to put layout. So this is where we're going to be defining our layout, and our layout will be called layout. So this is just a variable name, and I'm going to equal that to Qt GUI dot QGrid layout and open and close brackets. So from the Qt GUI, we've actually pulled in our Qt grid layout, which will allow us to actually place these into some kind of layout onto our window. Now to do that, we actually need to add the buttons to the layout. So layout dot add widget, and in here we need to pass in the actual button itself. So self dot BT underscore start, comma, and then this is the grid reference of actually where we want it to be placed. So if I place it at an X of 0 and a Y of 0, that means it's placed into the first column and row of that grid. So 0, 1 will mean it'll be in the first row, X, and the second column, because it's 0 based index. I'll go for 0, 0 at the moment. And then we just do the same with our BT stop. So self.bt stop, and now I'm going to put that next to it as 0, 1. Now we need to actually apply this layout to the window, and there is a command called self.setLayout, and then we pass in the layout in here. So that should mean, with any luck, we'll have a window with these two buttons on there. There we go. So those are sitting there, and as you can see, if I start to try to bring other windows in front of it, it will actually push them to the back. Let's close that down. Also, we can actually set the actual size of the window. So we're going to come up to this window here, and I'm going to place self.resize, and I'm going to give it a value of 200 by 100. So I've got a smaller window here. So that's our basic window all up and running. We now need to actually define some methods to actually call when you actually click the buttons. And I'm going to define the methods down here. So if I come in here, and I'm going to define a method that's actually outside the init now, because we don't want to do anything else in that init because it's all up and running. So the method I'm going to create is a click method for the button start. Okay, go button start click. Also we're passing self in there, semicolon. I'm going to call it what we want, and all I'm going to do is print button start click in there. And we're going to do the same for the button stop. Define bt underscore stop underscore click. Passing self. And from there, I'm going to just do the same, print button stop click. So at the moment, if I try to run those, we're not going to get anything because we need to connect these buttons up and do them in here. So to actually connect them up, we need to issue the command qtcore.queobject.connect, and that will actually connect up the buttons. So this actually takes a couple of variables. So we first need our button, so I'm going to pass in self.bt underscore start, comma. So next we've got actually passing a signal, and all these buttons and widget objects all have events, and when you actually click a button there's a pressed event. When you mouse over a button, mouse in, mouse out, all those raise events in the actual language itself. So we need to actually connect up that event, so we're actually listening for a signal, and we'll need the event qtcore.signal open bracket, and we're looking for the pressed, and there's a bracket there as well, open and close bracket there. We also need to actually pass in the method that's going to be run. So we're looking at the button start click there. So in here we put a comma, pass in the method, and then close the bracket. So what we're looking for is any signals raised from self button start that equal pressed, then we actually connect that to the button click. So we'll run the button click function of this class. So let's test that. As you can see, it's come up button start.click is not defined, and that's because I've forgotten to add the words self in here. It's got to reference this class. You can see nothing's been printed, and there is a reason for that. It's now because the print message won't actually work. We have to use app.console print message, and there you can see it's actually printed. And what I'm going to do is use that same command. So that's done. So let's hook up the stop button. So connect self.bt stop, qt signal.press, self.bt stop.click. Let's clear this out. See start and stop are coming through now. What I'm going to do is put a new line character in here, so they actually show on separate lines. There we go. So it's a simple interface up and running. Now let's use this to actually drive some animation. So that's quite simple. Because our animation is normally used with a timer, what I'm going to do is actually place a timer in here and use that. So in our constructor, our init, what I'm going to do is at the bottom here, I'm going to add self.timer. So I've created a variable called timer equals qtcore.qtimer, and open and close those brackets. So we've got a timer. Now we need to create a method that's going to be run each time this timer ticks. I'm going to create a method called timer tick. Open bracket, pass in self, close the bracket, a colon. And for the time being, I'm just going to app.console.print message, and I'm going to just show that the timer is ticked. So I'm going to put in here timer ticked. I'm going to keep that on the same line so we can actually see it go across. Now I need to attach the timer tick to the timer. So to do that, we just need to come in here and under here self.timer.timeout. So on the timeout method, we need to connect timer underscore tick. Remember that you need to add self before as well. Let's just check that to make sure it's running. So it's all good. So we've got self.timer in there. So we've got our timer defined and connected to our timer tick. So that's start and stop the timer. So in here, start click. I'm going to come in here and do timer self dot timer dot start and pass in. I'm just going to pass in 1 for a millisecond, and in the stop we need self dot timer dot stop. And if we run that now, we'll see, hit the start, our timer is ticking every millisecond. You know, I hit stop, the timer is stopped. So we can do that again, start, it's now started, stop, scroll down, so you can see the output, started, stop, there, stop. So that's all working. What we need to do is safeguard against this window closing whilst the timer is still running. And to do that, we need to intersect an event in here before it actually ends. So let's close this window down, and in here, if we type in define, let's put on a new line. We're looking for an event that's actually on the Qt widget, which is close event. And that takes self and event. And what we'll do is just show that first of all. So app.console.print message, closing there. What we'll do is run this and close it, and what you'll see in, let's just clear this, run and close, and you see that we've got a closing appeared there. And what we can do is just do self.timer.stop just to safeguard in here. So if we test this now, we'll just clear this panel, hit start. So the timer is ticking away there. Hit stop. Timer is stopped. Hit start again. Timer is ticking. If we close this, we can see that our close has run and our timer has stopped. So we should be all good. So now we'll look at actually running this against a scene. So I'm going to start a new document, and what I'm going to do is jump to the part for this one, and all I'm going to do is put a cube in there. So that's in our scene now, and I think what I'm going to do is just rotate this cube. So if we look at our Python panel, we see that anything we do in here will get reflected. So if I go to my cube and change one of the angles, you can see this is being changed, the angle is being changed, and we're getting a FreeCAD.get document unnamed, .get object box placement, and it equals the rotation. Now, I know our object's named cubed, it's named box here, and that's the internal name. So if I hover over here, you can see down the bottom left I've got pre-selected cube unnamed.box.face3. So we can actually see this cube is actually called box, the actual internal name. If I put another box in, and we'll translate that over here, we can see that cube 001 is here. It's labeled Q001. But if I hover over, you can see it says cube 001 unnamed.box001. Now the box 001 is the internal name, so we must take note of that, so we can't actually reference any of these by the names of these labels. And the reason is because these labels can actually be renamed and the same name used more than once. So I'm going to get rid of that cube, and what I'm going to do is I'm going to click on the cube and just change its angle and see what commands I get up in the Python console. So we've got FreeCAD get document unnamed.get object box.placement, and I want to change its rotation with one command. So I'm going to copy that part of the command. Now we've got FreeCAD.get document get object.placement, and then we know we've got dot rotation in there, and I'm going to increment that plus equal by 10. Dot angle, I'm going to plus equal that by 10, and you can see that's actually rotated. So we'll do that again, we can see it's rotating. Now I'm going to pick something a bit smaller, 0.1. So that's rotating around, so that's the command that we'll use. So all we have to do is just copy that command, Control C, go into our Python and have a look down here. So in our timer tick, where it's got timer ticked, in here we just had this command here, and just tab it into this timer tick. So that should run each time. So now if we hit play, go to unnamed and hit start, we get the rotation working. And we can actually move this about and see it at different angles. Close it and the animation will stop. Now if we look at the command that was used, the FreeCAD.get document, it's actually naming unnamed. So if we save this, that unnamed would change. So what we need to do is make this a bit more generic. So we can do that by changing FreeCAD to app and then get document to active document, take out the unnamed and just put get object there, and that should allow us something a bit more generic to use. So I'm going to copy that, jump over to my macro and paste it in here. There we go. So run that now. Hit start. That's swinging away there. So actually if I go and create a new document and throw a cube in there, because the cube is still named, if I can get it, there we go, box, still named box. As you can see, the internal name of the document has been renamed. That macro still works because we're getting the active document, so we can actually swap between the documents and have them start and stop the animation running on this animation here. So it's whatever one's active. So I hope you find that useful. So that's one way of actually creating a GUI to actually allow you to start and stop the animation. In my next videos we've got some A2 Plus and some assembly videos on my channel that I need to actually create interfaces for to allow us to control certain objects like digger arms, etc. And we'll use the same process for doing that, but we'll probably add some sliders in there and a few other different controls to actually control them. So there'll be controllers there that you can actually push and pull to actually allow the digger arm to swing out and swing in, or links to extend and contract as you so desire. Okay, so I'll see you in the next videos. If you like what you're seeing, please subscribe to my site, and also I have a Ko-Fi site where you can actually donate a few pence or a few pounds, dollars, or whatever your currency is, and that's at ko-fi.com/mang0, and there you'll be able to help me fund my site, and all the money that I actually get from any funds will actually get pushed back into the channel. Thanks a lot for watching and subscribing. I'll see you next time.